You are welcome to online lectures with From Eternity the Schoolboy. Today, we'll take a look at physics and we have a question on the board. The question says, in a collision between two objects, kinetic energy is conserved only if A. One of the objects was initially at rest. B. Potential energy is converted to work. C. The collision is inelastic. D. The collision is elastic. The question source is West Africa Senior Secondary School Certificate Examination WASSCE 2020 Physics. Objective question number 1. Now let's look at the question again. The question says, in a collision between two objects, the kinetic energy is conserved only if. So this question is from the topic collision in linear momentum and the law of conservation of energy and the linear momentum. So let us go into this relationship between the elastic collision, kinetic energy and momentum. And actually, when two objects collide, we have a head-on collision. When two objects collide, we need to determine what happens before the collision and what happens after the collision in terms of their what? The momentum and the kinetic energy. Of course, you know that momentum is mass times, momentum of a body is mass times the velocity. While kinetic energy is half mv squared, half mass times velocity squared. Now, when two objects collide, they move with specific velocity. Each of them, they have their respective velocity and their masses. Now, when they collide, and if you find that after the collision, they move the total kinetic energy and the total momentum after the collision is the same thing. The total, of course, before they collide, we have the total momentum and total kinetic energy before the collision. If after the collision, the total kinetic energy and the total momentum of the bodies remain the same or conserved, that means that type of collision is what we call elastic collision, perfectly elastic collision, because no energy loss, momentum is the same thing. Now, there's also a situation whereby the two bodies, they have the total kinetic energy before the collision, total momentum before the collision. After colliding, you now realize that the momentum will be conserved, they will be the same, but there will be a decrease in the kinetic energy. Now, what actually happens is that after the collision, they stick together. They stick together and move with the same velocity. Their velocity after the collision will be the same thing. So there's a high tendency of the total kinetic energy not being the same thing as before the collision, because they will move with the same velocity. So the total kinetic energy will now be something like this: half m. That's after the collision for inelastic. This, I'm trying to explain inelastic collision now. You have something like this: half mv, half m1, m2 v squared. Half m1 plus m2 v squared. Because after collision, what we have is this will be the same thing. Their velocity will be the same thing. Of course, you know that kinetic energy is half mv squared. So for each of the first body and second body, the velocity for the first, the kinetic energy for the first body is this. Kinetic energy for the second body is this. But because the velocity is the same thing after the collision, you now have something like this. You now have something like this. Because they share the same velocity, they have the same what? Velocity. Unlike this is inelastic collision. Unlike in elastic collision, where it will be the same thing. Initial moment, initial total kinetic energy before the collision will be the same thing after the what? Collision. No kinetic energy is lost. But here, for inelastic collision, kinetic energy is lost. There will be a decrease after the what? Collision. So, for inelastic collision, energy is not conserved for inelastic collision. But for elastic collision, energy is conserved. The total kinetic energy is conserved. The momentum is conserved. Inelastic, momentum is conserved, but the total momentum is conserved, but the total kinetic energy is not conserved for inelastic collision. So because of that, now let's look at this. Let's look at these options and choose the most appropriate option. Option A says one of the objects was initially at rest. No, it's not true because they are moving. So this is not what the answer. Before the collision, they were actually moving for them to have a head-on collision. B, potential energy is converted to work. They have no business with potential energy. We're talking about kinetic energy here. C, the collision is inelastic. No, look at it. It said, the question says in a collision between two objects, the kinetic energy is conserved. So in inelastic collision, kinetic energy is not conserved. So this is not the answer. D, the collision is elastic. This is the answer. This is in line with what I explained. In an elastic collision, the kinetic energy is conserved. The momentum is conserved. But in inelastic, the kinetic energy is not conserved. I explain what happened here. I use this to explain that of elastic is clear because half m 1v square 1 plus half m 1v square half m2 v square 2 will still give you the same thing. Half, this is, of course, this one is for initial. This should be the initial velocity u. Sorry, this is initial velocity u. So we still give you the same thing. Half m1 v. This now is now final velocity v 1 squared plus half m2 v2 squared. The total kinetic energy will always give you what? The same thing. So it's conserved. But in an inelastic, this is what you get. Half m1 v u. This is now u. u1 squared plus half m2 u2 squared. They will not give you the same thing. There will be energy loss. Because here now their velocity is now the same thing. I'm going over to what I have explained before now. So this is what happens in what? Elastic. In terms of kinetic energy now, because my focus here now is on kinetic energy. The momentum is conserved in elastic collision. Momentum is also conserved in inelastic collision. That's why I didn't bother going into momentum, where we have the differences in kinetic energy. That's why I focus my explanation on kinetic energy. This one is for what? Elastic collision. This one is for what? Inelastic collision. So the answer is what? D. All right. Thank you very much for your attention. Please, if you have any question, feel free to drop your question on the comment section. You can also chat me on WhatsApp if you have any question. Please subscribe to my YouTube channel. The YouTube channel name is From Eternity the Schoolboy TV. Follow me on Facebook. My Facebook name is From Eternity the Schoolboy TV. Share these lectures with your friends, with your colleagues, with your children, with your students. Someone out there may be in need of these lectures. And God will bless you as you do so. See you next time.